As we continue our review, we're going to be looking at exponents. Now, these are all rules that you covered in Algebra 1. Maybe you saw them even, well, I'm assuming that's where you would have begun with this. We're going to do them again at kind of a little bit of a higher level and a little faster. So, I have more detailed explanations of why on all of these in other videos if you want to see those. So I'm going to just kind of go through the summary of these. If you have two exponents with the same base, you can add them up. So there's 5t's here, 3t's here. If you thought about that as just a line of t's, it's t to the 8th. Well, the shortcut is just add those exponents. Now here on B, this is like you had negative 3 to the first. So I have the same base. I've got 5 of them here. I've got one more of them over there. I've got 6 of them. Now same here. I've got 5, 6, 7. I have 10 x's all in a row. I can just add those exponents up. It becomes x to the 10th. Okay, you can always pause and try if you want to yourself. I've got 15 k's here. All I have to do is add up those exponents. Now this is very strange, but all of this is being taken to the power, 2 over y. I've got 4 of them there, 1 of them there. It's like I have 5. Then I have, how many t's do I have? 11. I've got 14. All right. Now I'll tell you why in a minute this is true. But if you had if you're doing division and the bases are the same, you can subtract their exponents. So, well, none of these are easy. Let's start with this one. So imagine I had 23 t's on top and 15 on the bottom. I can cancel the matches. So let's do a simple one here. So if I had 3 x's on top and 2 on the bottom, I could cancel any matching. Those are factors. I could cancel the matching factors, and I'd have 1 left. Well, the shortcut is, that's what you're doing, but the shortcut is you can just subtract the bottom from the top. What happened was it was 3 minus 2, or 1. So we can always just subtract, so if the bases are the same. So I have 14 on top, 9 on the bottom. If I canceled them all down, there'd be 5 left. And if you think of it as subtraction, 14 minus 9, I get 5. So here for the one with the t's, I'd have t to the 8th, because I'm just subtracting them. Now, as strange as all this looks, all of this is to the 5th power, and there's one of them on the bottom. So I have z square root of 2. So 5 on the top, 1 on the bottom. I'm going to subtract that. I've got 4 of them. Okay, pause it if you want to try this yourself. But I've got 68 on the bottom, 75 on the top. I've got 7. That's supposed to be a 7. 7 s's left. Now on the second one, it's like I have one of these on the bottom. So if I canceled them down, or you thought of it like subtraction, 6 minus 1 is 5. Now this one's quite unusual. There's a little more we could talk about with this one, but we'll get to that later in this video. But I have all of this group being taken to the 5th, and on the bottom to the 3rd. I can subtract those exponents, all of that group to the 2nd. 5 minus 3. Okay, now a power to a power becomes multiplication. And so the idea would be this. Suppose I had x to the 2nd. Well, let's do an easier one. X to the 2nd, all to the 3rd power. What it means is you have 3 of the same thing, right? Now if I added these up, it would be x to the 6th. Well, the shortcut is to just realize that what you're doing is multiplying the power times the power. That's where the 6 came from. So these are equivalent, and I could do 2 to the 3rd is 6, or I could think of it like 3 groups of x to the 2nd, gets me to the same place. So a power to a power is multiplication. So I've got x to the 14th there. Now all of this is to the 5th power, then to the 3rd. So that's multiplication, be the 15th. This negative 3 is to the 5th power, and then the 11th. I can multiply that and get to the 55th power. Okay, pause it if you want to try. I'm taking a power to a power, so I'm going to multiply. I don't think I need those. I would do this. T to the 35th. And multiply power to a power. Now here the negative g, 4th to the 4th power, it's going to just turn out to be the multiplication. Get 16. Okay, now another important rule is that anything taken to the 0th power is 1. Now I can show you why that is, and if you want to watch one of the earlier videos, but I'm just going to refresh you here on these ideas. So, well, actually, this one's perfect for showing you. So, do you see that if I had c times c times c, and I reduced these down, I would have to be left with 1, right? Now, c to the third, but we also said you could subtract exponents. So c to the third minus 3 would be c to the 0th. Well, these can't be two different things. They have to be saying the same thing. So if these are both true at the same time, c to the 0th power has to be 1. So anything to the 0th power is 1. So this one becomes c to the 0th, and that's 1. Now here I'd have, if you subtract these exponents, I'm going to get negative 3 x to the 0. Well, that's going to be negative 3 times 1, or just negative 3. Now, this is quite a mess here that they've got. But if you see on the bottom, I've got 4 of these. So I could add, I've got 1 here and 3 there. So I can add this up. I've got this whole group to the 4th. I've got it on the top and the bottom. It's all going to cancel down to 1. Now, I've got, so working on D here, I've got 2 of them on the top. Got 2 on the bottom. So again, you could think of this, I even said it like this, you could think of it, these just cancel each other and they would become 1. But if you thought of it as subtraction, you'd have 5rs to the 0. 2 minus 2 would make 0. So all of that is always, no matter what it is, anything to the 0th power is 1. So 5 times 1 is just 5. Okay, so we're going to see some of the same here. You could think of this as 7 minus 7, so t to the 0. We're just going to get 1. You could also think of it as canceling these. Now, if they cancel, we've got to leave something behind. This is going to be 1 over 2. Now, I've got 6 w's on top, 6 on the bottom. I'm going to get 1. I've got 7 on the top, 7 on the bottom. You're going to get 1. Okay. Now a negative exponent becomes a positive by moving it across the fraction line. I can move it down. So it's going to have a lot of applications here. So let me show you how this would work. Well, yeah, let's think of it like this. If we subtracted the top from the bottom, I should get negative 7, right? Well, if I had, it'd be easier if I had, let me do x to the second over x to the fourth. So I'd have x times x. So if I cancel these down, I should get 1 over x to the second. But if I subtract them, I should get x to the negative second. So these things must mean the same thing. And they do. So a negative exponent becomes a positive exponent if you just move it down. So if I have theta equals negative 7, that's the same thing as theta 1 over theta to the 7th. So do you see if you canceled them down, you should have 7 on the bottom? Another way of thinking of it is if you subtracted them and got the negative exponent, you could just move that down below. So here on B, I've got z to the third on the top over z to the fourth. So if you canceled them, do you see you're going to have 1 over z? Another way to think of that is z to the 3 minus 4 is negative 1. So these things have to be the same. I could move it to the denominator and it becomes a positive. So these are the same, so I could subtract them, I get negative 4. Well, let's move it to the bottom and make it a positive. Okay, so do a few more of these. Pause it if you want to. So this would be the negative 6. So 2 minus 8 is what we learned. But to move it to the bottom makes it a positive. So here I've got f to the 47th over f to the 50th. You see there's really one of them there. I could add those up. So if I subtract them, I get f to the negative 3. Move that to the bottom to make it a positive. Okay, here I get 2. This is a little weird one. I'm going to do it like, I'm going to put the numbers out front. It means the same thing. And the k's, I'd have k to the negative 3. Now, let's move this to the bottom. Yeah, this is strange. But this is what would happen. It would go to the bottom. Or you could think of it, there are 3 k's left on the bottom after you've canceled them out. And here's where you would go. Okay, so we're going to put some of the rules together and start tidying these up. Now if I have common bases, I can add them. So I'd get b to the negative 6 if I added those. Now we could move it to the bottom, make it b to the 6th. Now I can add these because they have a common base, and I'd get negative x5 plus negative 5 would be 0. Anything to the 0th power is 1. Right, I've got all of these to the first power, all of those over 5. So I'd have negative 7z to the negative 4th if I did 1 minus 5. You can move that to the bottom, make it a positive 4. Okay, we can add these, get t to the negative 5th. Then I can move it to the bottom and get 1 over t to the 5th. Okay, on b here, a couple ways you could think of that, but it's 12 minus 13 gets me to 25 to the negative 1st, which is just 1 over 25. Okay, another property. I know we're moving fast here. I hope it's a refresher for you, but it is important. So again, if you want to go slower, I've got some other videos. When you've got this exponent here on the outside of this group, you can really think of it as that exponent can be distributed, like given to both of the numbers inside. So let's do it with some real numbers. I can give this 3 inside to both of them. So a is being cubed, and now it's like b to the 2nd to the 3rd. It becomes b to the 6th. So I've given that exponent to both of them inside. So here with the 15th, it would be 2 to the 15th and t to the 15th. Now that 2 to the 15th is a real number. We could find that, but it's not necessary. It's going to be really big. So, okay, so again here, I could give negative 2 is going to get that exponent. And so is w to the 3rd. So think of it like that, I guess would be a good way to show you. Now this one's easy, so we should finish this. That's going to be negative 8. Now w to the 3rd is going to be w to the 9th, power to a power. Okay, I wasn't sure what what's happening with d, but so it would be like this. We're giving the negative 7 to the 4th, and the z gets it as well. Now this is a big number. We could find that. I guess, yeah, I don't like leaving that as... Yeah, so this would tidy up to be 1 over z to the 4th. Okay, we're given this 7 to both of them. So we have powers to a power, so this is e to the negative 14th and f to the positive 14th. Now I wouldn't want that negative exponent typically, so I would move that e to the bottom. Okay, we got a few more here to work through, and I think things are going to get real cool. Well, we got some more rules. This is quite a long section, so hang with me here. I'm going to go a little faster here for the sake of time. I'm going to send that 5 to both of them. So g to the 2nd to the 5th, g to the 10th, and h to the 3rd to the 5th, h to the 15th. Now this would become 5 to the 3rd, which turns out to be 125. Oh wait, does it? 5? Yeah, it does. And then t to the 3rd. Now I'm giving this negative 3 gets a cube, so that'll become negative 3 to the 3rd is negative 27, and y to the 15th, power to a power. Here I'd give that cube to both of these. I'd get a to the 18th, b to the 21st. Give this 4 to each of them. Now I could move that r to the bottom, or the s to the bottom, and get s to the 8th there. Okay, so another rule here is if we have a fraction with an exponent, we could give that exponent to both the top and the bottom of the fraction. So let's go ahead and do that. I'm going to again do this quickly without showing. So I'll do one here to show you that. So I get 4 to the 3rd, and then z to the 11th sorry, 4 to the third. See, the 11th is also going to get to the third. So what is 4 to the third? Oh, easy one, sorry. 64 over z to the 33rd. Power to a power. Okay, so I'm going to give the 6 to both the top and the bottom. It would get p to the 6th. And q to the third to the 6th. He's going to get it as well. It would be q to the 18th. Now, -1 to the 27th, and then t to the second will get the 27th as well. So this is an odd number. So -1 to the 27th, do you see that actually becomes just -1? So we'd have 27 negative ones in a row. It's going to be a -1 at the end of that. And t to the second to the 27th becomes t to the what? 54th. Okay, now we saw that we can give, this is not a fraction again. Well, it could be. They're being clever here. I'm just going to give it like we did on the last one. Give the 4 to everyone inside of there. J to the third to the fourth would be j to the 12th. I'm jumping ahead of myself. K to the -2nd to the fourth. So that would be k to the -8. Now, this is how it's like a fraction. I can then move that negative exponent down to the bottom. And I get this. Now, let's do it again. I'm going to do it like in the last section where I'm going to give this exponent to everybody. So m to the -6, n to the -6th. Now, let's make these positives. Let's put them on the bottom, but you can't leave the top empty, so we're going to make this. Okay, so I'm going to go through these quickly, but pause it if you want to try them all before you look and see what I've done. Okay, I'm giving this third power to both the top and the bottom, so I've got b to the 15th over c to the third. Now, on this one, I'd have 5 to the 4th over u to the 32nd. Now, I could find this number, but 125 times 5, what is it, 575, I think. Okay, on C, -1 to the 35th. And W, 3 times 35. What, man, these are some crazy ones. 15, 105, I believe. Yeah, I believe. Okay, so if I had 35 negative ones in a row, because it's an odd number, it's just going to become -1. Okay, I'm going to give the 4 to everybody inside of there. Or did I miss one? Yeah, I did. I should be on D here, so let's go down here. Okay, so I'm going to give the 8th power to everyone inside of there. So I've got p to the -32, q to the 24th. Now let's get rid of the negative exponent by moving it down below. Now one more here. C to the -20th, d to the -12th. Now let's move all of that below. Let me get this. Okay, I think that's all that's left is a whole bunch of really crazy ones. So let me see if I can let them walk us through and save me some writing. So I would give this third power to everyone inside. Now we have some powers to a power here. We have a negative n. We're going to drop that down. Now we have a whole bunch of 17s, all the same bases with a bunch of exponents. We can just add those up. We'd wind up with 17 to the -2nd, which we can move to the bottom and actually find the number. Now, I can give the square to everyone, both on the top and the bottom. So I'm giving it like it's on the top like this. I actually like the way they did that. And now I can give it to the square to everyone inside of that top. Do you see how they got from here to here? Okay, well now I've got v to the second on the bottom, v to the -2nd on the bottom. So that's like v to the second minus -2. Two negatives make it a positive. That's where they got v to the fourth. Then their final step is they move the u to the bottom to make it a positive. Okay, now with all of this being multiplied here, I don't think we've seen this first. What I would do, you're putting together all the like things, multiplying together the numbers, putting together the a's, and putting together the b's. And when you do that, you get down to this row here. So 3 and a -2 add together to make 1, b to the negative first and b to the second add together to get 1, and you get down to this. Yeah, this is a really crazy one. This is all a group. So, well, actually they were being crazy, but it's actually pretty simple. So the groups of the bases are the same, so I could add those exponents and the exponent becomes 0. So anything to the 0th power is just 1. Oh, I have one more. Okay, so on the top, I'm going to give this 5th power to everybody. On the bottom, I'm going to give that square to everybody. Now we've got some tidying up. I've got some w's on the top and the bottom. You can think by 10 minus 4 makes that a positive 4, gets me 10 to the 14th, or w to the 14th. Now, yeah, let me see, this is the last one. So let me take you through this one. So when I follow through theirs, it's not always super clear what's happening, but let's go through. So I'm going to give this negative 3 to everybody. Now, a power to a power, I would multiply them. And what's interesting is the negative 2 and the negative 3 are going to make a positive 6. Now, I'm going to move these to the bottom. So I've got v to the 6 over 2 to the 3rd u to the 3rd, just by moving them to the bottom. Those are u's. Now, 2 to the 3rd I could tidy up. I get v to the 6 over 8 u to the 3rd. Okay, all of these are the same base, so I could just add them up. So I've got negative 4 plus 1. I get x is negative 3, I believe. I could move that to the bottom. Okay, you know, what I would do here is I would first take care of the f's are the same, so I would tidy up what's inside of there first. So if I had f to the negative 3 minus negative 1, because I'm doing division, that would be f to the negative 3 plus 1, or f to the negative 2nd. So all of this tidies up. Let's do it like this. To this. Now, let's give this exponent to everybody. 2 to the 2nd. So squared to the 2nd power is the 4th. This becomes f to the negative 4th, power to a power. And then I can move it to the bottom. Okay, here, I'm going to multiply the numbers together. I'm going to put the r's together, and they're like bases, negative 5 of them, 6 of them there. I'd get r to the 1st. I've got 3 s's here, negative 4 s's over there. I'd add those, get negative 1. So let's move that s to the bottom. Okay, I was looking at this thinking it was going to be horrible, but I have all of this to the negative 3rd and the same thing to the 3rd. I could add that up, and I get to the 0, which is 1. Okay, final one here. I'm going to give this 4th power to everything inside. 2 to the 4th, h to the 8th, k to the 4th, over 7 to the 2nd, h to the negative 2nd, k to the 4th. Okay, now these are the same, so they'll go. I'm going to move, so you can think of it like moving these h's from the bottom to the top is going to make h to the 10th. Does that make sense? Anytime you cross the line, so if I have a negative on the bottom, it can cross to the top and become a positive. It works either direction. But another way to think of it is h to the 8 minus negative 2 is h to the 10th. You'd get the same way 2 different ways. So 2 to the 4th, h to the 10th, 7 to the 2nd is 49. 2 to the 4th is just 16, right? Okay. All right, that's a whole lot of rules if you're not real comfortable with it. So I have slower paced videos if you want to check that out. But again, they're foundational. You'll use this stuff a lot. This is pretty important stuff. So watch through this twice if you need to. And then again, we've got the homework you can try to practice with.